Good afternoon, everyone. I'm Ashmitha, and today we will be speaking about fiber optic sensor. Okay, so when we speak about fiber optic sensor, we can split the term into two. That is fiber and optics. So when we speak about fiber, we all know fibers are, when we think about fiber, the immediate thing that comes to our brain will be few fragile wires, correct? So yeah, that is fiber. Maybe something like roots, very thin wires. We can keep it like that. And next we see is optics. And when we speak about optics, the thing that comes to our brain will be about our eyes. So yeah, what does an eyes do? It takes in light, it senses, transmits, it processes, and it will give us an output. That is, if I'm seeing a water bottle in front of me, the light shows that okay, the light, my eyes takes in few lights, the wavelength, the indexing, everything it takes in, it processes, and it tells me, okay, I am seeing a water bottle and I can drink the water in it. That is what my brain processes. So now we are completely mimicking the same idea into a sensor, okay, through wires. So fiber optics is something that is, it is circular dielectric wave. It guides the waves and can be transported through an wire. It actually transports or guides the waves of an optical energy, and it converts that into electricity in further processes. So let's see what a fiber optic sensor is, main mechanisms, introduction, everything we'll have a look. Now, yeah, let's get into the topic. Yeah. So when we speak about fiber optics, okay, the fiber optics we speak, it is a sensor technology. We will speak about basic classifications, basic functions, and basic mechanisms of a fiber optic. So when we think about this fiber optics, the scientist who brought this was Dr. Lumino. Okay, so the plan was, when we go into his place, we it describes that his lab consists of so many fluorescent lights. That is, he is always completely in glow. That is, he's covered with lights. So we all know he's working with something with lights, and he has found optical fiber sensor. So in this fiber optic sensor, the main thing is we can transmit light through a long distance through wires or fibers. So that is the main concept of this sensor. Okay. So when we speak about this sensor, we know strands of glass can carry great distance of light. So it is untethered by electromagnetic interference, and it has the inability to it has an inability to conduct electricity. Yeah, sorry, I was searching my notes. Yeah. So the main two thing is, it is insensitive to electromagnetic interference, and it has the inability to conduct electricity. These are the two main things. And when we speak about a fiber optic sensor, they are small in size and they are light in weight. They can handle high temperatures, that is extreme temperatures that can be handled. So we don't have to make a separate model or create a separate sensor for looking into diverse conditions of the environment. Then when we see, it is very sensitive. That is, even a minute change in the environment, like if there's a minute change in temperature or the pressure, or if there is any unduly vibration that suddenly happens, even that can be sensed, and the parameters change according to the environmental physical changes. So that is fiber optics. So when we speak about the fiber optics, I would like to tell you about this basic photo, or the picture we see here is a very basic one which we have studied in our school time itself. So we can see we have a wire. The outside is called the cladding, and it has a low refractive index, and the inside is called a core, and it has a high refractive index. So what does a high refractive index do? A high refractive index helps in higher refraction. As the name says, it's very simple. It helps in higher refraction. So what is refraction? Refraction is like bouncing, or it moves away from a point And that point can be a focal point, and it's very simple. A light, just imagine a number of photons entering a wire, and this wire has, and these photons, they're in dancing mode maybe. Yeah, so yeah, they're in a dancing mode. And when they enter this, they just drift away. They move in they don't move in a steady flow. They just go in whichever direction they like. They refract as much as they can. So for this refraction or for bouncing effectively, we need a higher refractive index. So we have the core designed in such a way that the inner portion has higher refractive index, which helps in transmitting light over long distances. Okay. Yeah. So that is the main thing. And when we speak about the real world applications, we can take in about the measure of flow of fluids. We can detect leaks, integrity of bridges, and health conditions of patients. All those things can be connected and can be solved using fiber optic sensor. Okay. Basically, it's sensing. It doesn't helps in curing, but it helps in sensing the problem out. Yeah. So that is the basics that we have to know about a fiber optic sensor. Now, let's get into the topic much deeper. So when we speak about a fiber optic sensor, a fiber optic sensor is a sensor that uses optical fibers as the sensing element. Optical elements is they're the wires. So we use wires as the sensing element. So the basic components we take is light is taken to modulation region. So this modulation region is like how we see the term called fidelity, where we don't change its physical nature, but we, that is the, if an input is a sine wave, then the output is also a sine wave. That is, we don't change the nature of the wave, but we modulate it. That is, we make it suitable for a particular application. That is what is referred by modulation region. That is, we convert the physical parameters, maybe a temperature, maybe a vibration, or a strain, a rotation, anything it can be, that is modulated into a light accepting phenomena or a physical parameter, and then we are getting it as a output. That is the main process that happens here. So it is modulated there by a physical or chemical phenomena, and modulated light is transmitted back to a receiver. Then it is detected and demodulated. As we all know, what does a sensor do? It senses. That is, it detects. It detects if there is any change in the incoming signals. Yeah. So it senses it. Next, when we are going to see about the flow diagram. So as mentioned, we have a source. Let's take an LED with around a good intensity of light, amount of light that passes through a wire. So that is the source is the LED here, and the optical fiber is the wire. Then you have a transducer, that is a measurement. That is, it's the process. It's simply like our brain. We give an input, it processes, it analyzes, it interprets, it detects, and then it gives a report, or it's like you change it or you modulate it. That is the measurement here, the transducer. It measures, and then it will detect if there is any change, or if there's no change, and then it will send it as an output. That is for us through a display, through an analog display or digital display, we will know what the parameters are. That is in numbers. We get the. So I have explained here the flow diagram using few main stuff. That is a start. So the process begins with transmission of light into the fiber optic sensor. It transmits light through this optical fiber to the sensing zone. And at the sensing zone, that is the modulation zone, what happens? Changes in the environment affect the behavior of the light traveling through the fiber. The changes in the light signal caused by the environmental changes are detected at the output end of the fiber. That is, the changes are which are modulated are detected at the output for us to work on it. Okay. Yeah. So next we will analyze the light signal. So we have analyzed and determined if there's any change in the environment. And I've given you two conditions, that is yes or no. When I speak about yes condition, that is if a change is detected, then the system will proceed with modulation, then it will come back, then again it will be sent as output. That is a process. And if there is no change, detected, then what happens? It is in a steady state. That is, there is no change. The physical parameter we get in has nothing to do with changing or processing. Correct? Yeah. So the first thing is, if there's a change detected, we will send it for modulation. It will come back to the receiver. Then it will transmitted signal will come back to the receiver. The receiver processes it, analyzes it, sends it as the output. And if none of this is happening, then there's no change detected. Input, no modulation, directly going to output. So that is the flow diagram. Yeah. Then we will, as said, output result will be displayed, and then we will end the process. That is the flow diagram. Yeah. So while speaking about this, I wanted to give a quick analysis on, not an analysis, maybe different types of, different types of sensor, different types of fiber optic sensor. So while speaking about different types of fiber optic sensor, there are two types of fiber optic sensor, that is extrinsic fiber optic sensor, intrinsic fiber optic sensor. So we, as mentioned here, the extrinsic fiber sensors are ones those where the light signal modulation occurs inside the optical fiber and they are delivered by optical fiber. That is, you have a light source and you're giving an input fiber. You have a light modulator, okay, and the green one is the environmental changes. Okay, in extrinsic fiber, you have a light modulation will occur outside the optical fiber. That is, you have a wire. Okay, the change or the modulation change will happen in the external region. Whereas in intrinsic, you can see that the changes or the processes happen inside. That is, we don't have any external factors that will help in modulating it. We have an internal structure that helps in changing or processing the optical fiber. Okay, outside the optical fiber and are delivered by optical fiber. The light transmission depends on the alignment of fibers core, that is input fiber core and output fiber core. So the light transmission will depend upon the input, that is the core, and the output fiber core. The light is detected by a lights detector. Any deviation of the fiber pair from perfect alignment is immediately sensed by the detector. That if there is any change, that is if the alignment of the fiber reduces or increases or length increases or any dimensional change, it is detected. Okay, the alignment is perfectly detected and it is sent immediately. So when we speak about extrinsic optic fiber, it will utilize the optic fibers as medium to transmit light to an external sensing element. Okay, so in these type of sensors, the optical fiber will act as a conduit to carry light to separate sensing elements, where the actual sensing process will takes place. The light will interact with an external sensing element and it uses, like, it could be like a physical transducer, like a pressure sensor or a temperature sensor. That is, the light will interact with an external transducer. Yeah, that is, it's a integration of two sensors, that is fiber optic sensor and a pressure sensor or a temperature sensor or something like that. Yeah, so I'll give an example. Okay, let's take an fiber optic cable. It will carry light to a pressure sensor. Okay, placed at a very high environmental pressure. Yeah, like oil well, maybe oil reservoir maybe. Okay, yeah. Now the pressure sensor will detect change in pressure, and these changes, it will modulate the light traveling in the fiber. The modified light signal is then sent back through the fiber and it is analyzed. So here what happens? Here the pressure sensor will identify the change in pressure and it will modify the light signal into the fiber, because an external input is given, that is the pressure is experienced by the fiber, so it should be modulated and changed. So if there's a change, yes, there's a change. You modulate it, yes, then it will come back. Yes, it will interpret, it will analyze, and then it will send us an output. Yeah. Okay. Super. So when we speak about advantages of an extrinsic optic fiber, we know its versatility. That is, it is easily adaptable. It can be easily adapted to many situations. And now I said a high temperature, that is an oil well with nice high pressure, it can survive that. Then it has a flexibility. That is, it can be used in any environment. It can be used to any external sensors. Like I said, no, it is like you can use it to a temperature sensor, a pressure sensor. You can use it anywhere. So this is the basic working of an extrinsic fiber optic sensor. Okay. Now there's another type, that is intrinsic. Okay. Yeah. Yeah, we have an intrinsic fiber optic sensor. So in this intrinsic fiber optic sensor, the physical parameter changes some characteristics of propagating light beam that is sensed. Here, the optical fiber itself works as transducer. Only a simple source and a detector is used. So there, what happens? We are giving an external transducer. Here, the optical fiber will only work as the transducer. That is, it directly modifies or modulates it. Okay, so intrinsic fiber optic sensor have the sensing element integrated directly into the optical fiber, as already mentioned. Yeah. Now we will see how they work. So if you see the diagram, we know it is, there's a light source, there's an optical fiber on the transducer. That is, it is wounded on the transducer. In the previous example, if we see, the modulator is separate and the environmental change is separate. And like the transducer is separate and you don't have anything there. Here, if you see, it is directly sensed by the wire. So without any need of any external sensing element, it can detect the change in temperature, strain, pressure, any parameters or behavior of light traveling through the fiber. Yeah. For this one, I can give an example. Okay. So when we speak about this one, have you heard about FBG sensor? That is, okay, I have noted down some new applications for that. One such application is fiber Bragg grating sensor. So what happens there is we have periodic variations in refractive indexes of the fiber. That is, at each point of the fiber, you have different refractive indexes there. Okay, which will so at each point you can't keep a specific amount. That is, I said, right, every place of the core will have a higher refractive index. I didn't say it will have a constant refractive index. It has a higher refractive index, but at multiple places it will be different. That is what happens in intrinsic fiber optic sensor. Okay, so each reflective element will have different specific wavelengths of light. So what happens? You don't have to modify it using an external either. Instead, we already have an inbuilt fiber where refractive indexes are different, so they will change accordingly. So that is, if you have a wavelength of 340 nanometer of light, of a wavelength of red light, violet light, if I send it through it, it can change, it can refract the violet light at its maximum. So yeah, I think intrinsic fiber optic sensor is something that we don't have to give an external source. Instead, it by nature, it is used for um, changing its self into transmitting light at different refractive indexes. Yeah. So that is a Bragg grating sensor. Yeah. It usually senses strain and temperature. Yeah. So that's what intrinsic fiber optic sensor does. Okay. So when we have to see a comparison between extrinsic and intrinsic, we will know the sensing principle. That is extrinsic sensor. That is the sensor that I talked about, oil well. That is high temperature external transducer we use. They rely on external sensing elements, whereas the intrinsic ones, they are often preferred for high precision measurements, and they have an optical fiber that has inbuilt modulating features within it. If we see installation, extrinsic sensor, they require additional components for sensing, whereas intrinsic, they don't need any additional components. They are by nature completely perfectly fit for transmission of light to a long distance. Yeah. So, but the thing is, both are, we cannot say their drawbacks are higher because each of them are used in different places, that is different categories. So both of them we cannot give any other, we can not say one is lesser than the other. That is the main okay. So now I'll be discussing about few important mechanisms of fiber optic sensor. So we have intensity modulation. So when we speak about intensity modulation, it changes in the physical parameter and it causes variation in the intensity of light. Okay, yeah. So the variations are detected, change in detected, it is measured and it is determined to the magnitude of the parameter. So it the mechanism is the change in intensity of light. Okay, when the light changes, intensity light changes, the modulation also changes. That is a greater amount of light is fed, that or the diameter of the fiber is more, greater amount of photons will go in faster and multiple refractions takes place at a single time. That is intensity of light entering it is more, which results in transmission, that is changing or converting the opticals or the photons present in the input and modulating it. It takes higher time to modulate it and then give it as an output. So that is an intensity modulation. And next one is speak about a phase modulation. The phase-based modulation of a fiber optic sensor, it changes in phase of the light transmitted through the fiber. So it changes in the physical parameter, induces the phase shift in the light signal. So phase shift is angle. So usually there's a 60-degree angle between each. Usually the light refracts at 60-degree, but here if there's a phase shift, it can be plus 5-degree. 5, not it's a 5. Okay, 5. Yeah, it can have a plus 5 or a minus 5-degree. Okay. Yeah. So next we will have a interferometric technique. Okay, the name is very complex, but the matter is very simple. So we use this in the interference of light waves, where we measure the length of the refractive index of the fiber. Okay, so that is we will measure the length of the fiber. Okay, so we can do this using interference patterns. The parameter can be actually determined with the help of these interference patterns. That is interferometric technique, where we will use integration of multiple lengths or multiple angles of the light, and then we'll be analyzing on the physical parameter that has changed, that has caused the process to change. So yeah, that's that. And then we have fiber Bragg gating. Yeah. So if you have listened to my lecture, you must have heard this word called fiber Bragg grating, because I've spoke about this just 2 seconds back. Okay. And if it was an online session, I should have if it was an offline session, I would have definitely asked some questions on it. But since it's an online, okay, let me just give a recap on what a fiber Bragg grating is. Okay, so in fiber Bragg grating, what is it's used in an intrinsic fiber optic sensor. So the example I gave for intrinsic fiber optic sensor is fiber Bragg grating. So yeah, what is fiber Bragg grating sensor? So it's a sensor where it has multiple places with multiple different refractive indexes. That is, it adjusts its refractive indexes according to the input coming in. That is, you don't need an external thing. The modulation is done internally. So when you see in FBG sensors, we use periodic variations in the refractive indexes. That is, we use fibers to reflect specific wavelength of light. Change in physical parameters alters the spacing of the grating. That is, when each photon refracts, you have very small place in between them. That is, the spacing is less. So with this, if you have okay, if you are giving a constant refractive index, you know it will fall, it will refract as a pattern. That is, you have a photon here and a photon here, and you just refract it. They come as a pattern. That is, they come in the equal spacing between them. Correct. But if you have a proper refractor, that is, it doesn't block the way of a photon to reflect. That is what we use in fiber Bragg grating system. So most of the places we use this for faster and quicker application, whereas here we are using it for a lesser time. Okay, so extrinsic we'll use it for some other purpose, whereas fiber Bragg grating we use it for intrinsic type of fiber optic sensor. Yeah. Okay, so I want to talk as we have reached the final part of our session today. I would like to speak about some applications of these sensors, that is fiber optic sensor, as we have spoke fully about it. Yeah. So fiber optic sensor, we have we use them in health monitoring, that is in the integrity of bridges, buildings, aircrafts, everywhere we use it. And we also use it in oil and gas industry, where, as mentioned, oil wells, for measuring temperature, pressure, everything. Yeah. So in medical diagnostics, we can say we use it in monitoring vital signs, detecting tumors, the guiding surgical procedures, and many more. So while speaking about a sensor, the sensor cap, it is actually coated with a phosphor attached to the tip of the sensor. Okay, now why do we do it? Because it detects the section inside to measure light. So this is what happens in a fluorescent substance. If you see a fluorescent bulb anywhere or fluorescent color anywhere, you can directly think it has phosphor in it. That's the reason why it is in that color, and you can like see it in a very clear manner. Yeah, that is that. And I have some external notes as well. I'll add into it. That is, you have a distributed measurement, that is the fiber optic sensor. It will allow the user to carry out measurements at different points of transmission line with loss when signal passes through it. So definitely losses is present, but we will maximum try to reduce the losses. So it helps in monitoring extended length or area as well. So if we see the disadvantages, what can we say? It has a detection system may be complex. You have to give an external installation module or a method for taking this process in. So as said, basically you're modulating a light and giving an output, and you're transferring the light through pipes or wires to a longer distance. That is the basic, simple, fundamental of a fiber optic sensor. Yeah. So while speaking about this fiber optic sensor, everything that came to my mind is my 10th standard portions, where we have all seen this image, right? This refracting images. Yeah. So speaking about this topic, I had a great immense pleasure, and I thank sir for giving such an opportunity to present. So yeah, thank you so much. I hope everyone has understood about fiber optic sensor. And if there is any doubt or any query, kindly contact me. And if I have to give a summary, then we have spoke about the introduction, the application, the principles, intrinsic and extrinsic type of fiber optic sensors, the mechanisms, that is the final mechanisms I spoke, which is intensity modulation, phase modulation. Intensity is the amount, phase is the angle, interferotechnic is integration of the length of the refractive index, and then we have spoken on fiber Bragg gating, that is we have inbuilt wires which adjust themselves according to the refractive index of the light entering it. Okay, so yeah, that's it. I think I have done justice to the structure I've given, to the sensor I have taken as my part. I hope all of you enjoyed it. Thank you so much.